I'm Joran from Joranalogue Audio Design. First of all, I'm very happy to be here in Rome and present to you Step 8, which is our latest module, and it's been a long time coming, but we're very excited. Next week Tuesday is release date. So today I'm going to take you on a little patching journey with Step 8. And I'll be honest, this module is still something I'm exploring myself, and I've been working on it for years. Because the versatility, it's so open-ended, and we're really excited to share it with everybody. So right now, I've just made a very simple patch. We have 2 oscillators with some phase modulation going through a filter, and Step 8 is driving everything as a simple step sequencer, which is, when people see the module for the first time, you see 8 faders, and you can change the faders to get different sequences. So that's the most basic application, but it's much more than a sequencer. Step 8 is born from the idea that sequential modules, sequential systems are often very similar. So you have sequential switches, sequencers, analog shift registers are all driven by a counter. Step 8 presents a new type of modular building block where all of these functions are available in one module. So how does Step 8 work? We have a sequential switch, 1 to 8 analog signal switch, and on each of the outputs is a high precision track and hold stage. So that means that every output has an analog memory. It retains the voltage. So if I set this switch, the solo all switch, to the middle setting, now the module works more like you would expect from a simple 1 to 8 sequential switch. So each output becomes active in turn, and we have our input, which is a 5-volt normal, sent through each of the outputs sequentially. And then each of the outputs have an attenuation slider, and that's how we can create a sequence, by attenuating for every step, differently attenuating this 5 volts down to a lower voltage. So now we have this simple sequence running, but after a while it gets a little bit boring. So let's change this input. Now the 5 volt is gone. And let's put in an orbit tree. Now we have something else going on. So what's happening now is that Step 8 is working as a sequential switch, stepping through the same inputs, but every time you get a different level of attenuation from our orbit tree. And I can turn up the frequency. And let's make some big. So you see the difference when the slider is high, the signal from orbit tree is used to frequency modulate our oscillators more than when the sliders are lower. So here already you see you can do some interesting things just taking a simple LFO waveform and then sequentially attenuating it. If I set the all mode, now you see the voltage memory in action. And each of the 8 stages will now retain the voltage. So what happens here is that every time we go to the next stage, the old stage will hold its voltage. And this is very powerful. So right now we're not using the voltages from the stages directly, we're using the scan outputs. And the scan output simply takes the active stage. You can see on the bottom where the gate outputs are, the LED is scrolling left to right. So you see the stages being selected sequentially left to right. And the stage output simply takes the analog voltage from the stage that's currently active. Now if I take any of the outputs, I get a voltage. And let's use this voltage to instead modulate our two oscillators. And now you see every time the sequence, let's say, passes this stage, the voltage gets updated. But while the stage is active, it's following the input voltage. So you hear the orbit going, doing its little thing, and then it holds the voltage. And if I make it faster, you should hear it better. There's also a sample mode, and here you don't have this, there's no tracking. So every time the module goes to the next stage, it takes a very short sample of the voltage at the inputs and retains it. Now this is the most basic mode, cycle modes. In cycle mode, the module works like a sequential switch. If we go into shift register mode, now it becomes really interesting. We have an 8-stage analog shift register, and you see the voltages going left to right. And this is something unique in Eurorack, to have 8 analog shift register stages. You can imagine the possibilities here, especially in bigger systems, where you can have 8 different parameters, all being CV controlled. And every time the patch goes to the next step, another parameter changes. So there's lots of possibilities there. But it doesn't end, because now we're just using step 8 at low frequencies. As a simple stepped sequencer, there's manual control. So you have a button, very useful. But there are also all these in and outputs, control in and outputs at the top. For example, we have a pause input. And if I just plug in the clock signal again, I can use a switch to control the step. So now it pauses the sequence, but my envelope is still running, so I can like freeze the pitch. I can reverse, go left, right, also under gate control. And there's a trigger input as well to reset the counter. Now step 8, although we call it a sequential tracking sampling register, is not limited to sequential use. There is a stage input, and this is used for CV addressing. So let's remove the step inputs and take stage voltage. Now something interesting is happening. What we're doing here is controlling the stage using analog voltage from orbitry. And if I quickly let's see, take this. So now orbit 3, which is our chaos oscillator, is controlling step 8 and moving the shift register left and right. So it's shifting voltages forward but also backwards, and you can see it happening live here on the sliders. But orbit 3 is also providing the voltages for step 8. So it's already clear that this is not something you can do with just an average 8-step analog sequencer. So let's try something else. Let's take this scan outputs into a mixer, and we'll increase the frequency of our orbit 3. here we go. What you're seeing here is the same stage action, but it's happening at audio frequencies. So this is quite chaotic because we're using orbits. But we can also switch to using, for example, generate tree to create a simple saw wave. And now what's happening is the saw wave from generate tree is stepping through all of the stages. All of the stages have a different attenuation setting. And I can create waveforms. I can draw waveforms right here on the front panel. So this is very much like you would take a step sequencer and clock it at audio frequencies. Step 8 will do that as well. So the step input will take audio frequencies, but it also does so on the stage input, which makes it like a kind of waveshaper, but a very interesting waveshaper, where there's different discrete steps that are being stepped through to create a waveform. Let's see what happens if instead of 5 volts we take, well, the output of generate. You get different waveforms. Some interesting timers in there. And of course these outputs on the top, they still do their thing. So we can take a pause output or rather the reverse input. So at first glance, step 8, it looks like a step sequencer, but we're trying to show people that there's so much more if you're able to, or if you're willing to think a little bit further, think of modules as modular building blocks rather than just these preset functions. There's so many possibilities that you create, and I think, or I hope I showed this with this very short and very simple demo of step 8. I'd also quickly like to give you an overview of what else we have available and also coming in the series. So we have in this nice system we've taken here the most popular modules. We have like filter 8, generate 3, contour 1. So we have a multi-mode filter that's also an 8-phase oscillator, slew limiter. Generate 3 is our multiphonic signal generator, which you just heard, which doesn't just have frequency modulation and different waveforms, but also true zero phase modulation and true zero amplitude modulation of different channels. Contour 1 we've been using here as a clock generator, as an it's again a module that does so much, and it's almost for us, for our team, it's almost overwhelming to see all the possibilities when you create a system like this where there's CV control over everything. There's all the kinds of modulation you might want. So it's something we're really happy to share with people. So step 8 is coming next week, and I think there's still some units left available, but we're hearing from our dealers that that they are going very fast. There have been pre-orders open for a little while now. Also coming next year, we have Delay 1 and Pivot 2. And Delay 1, let's see if we have some sound here. Delay 1 is our forthcoming high-end BBD module, where we've really focused on getting the best possible performance out of the BBD concepts. So Delay 1 is focused on short delay times, but at very, very high fidelity, low noise, low distortion. It's a great sound design tool, like you've heard here, with voltage-controlled feedback damping, voltage-controlled feedback amount, dedicated plug input for carpless strong, volt proctive, and many, many more features. And then Pivot 2, I'd also like to mention, is a series parallel router. So it allows you to take two modules, effects, filter, delay, wave folder, put them in series, in parallel, or series the other way around, reverse series, or anything in between with one knob. So this is actually a very nice module if you have some patch going on and you want to add some interests in the signal chain. With just one knob you can reconfigure it, which otherwise would take a lot of patching, and which is not that, having to repatch a big part of your patch is not that creatively inspiring. So that's what the Pivot 2 is all about. So that's a very quick overview of Step 8, as well as a bit of the series of what we do and what's coming next year. So I hope you enjoyed this presentation.